Hello, students. This is a very good question from mechanics. I was making a question related to a thin rod. So I thought a related question can be this one also. Okay, so I created this question. You can attempt it yourself. Okay, if you cannot solve it, then only look at the solution that I'm going to provide. So, although this is not a very new kind of question, but it requires lots of concepts that is taught in rotational mechanics. So, if you have understood most of the concepts of rotational mechanics, then only you will be able to solve this question. So, this actually challenges you to think and apply. Okay, so I would urge each of each one of you to first give it an attempt, and if you cannot solve it, then only you look at the solution. Okay, so here I'm going to provide solutions. See, this is a thin rod, and it is rotating about this vertical axis. With this angle is not given here. You see, the angle is not given, only angular velocity is given. Okay, so let's say this angle is theta. Okay, now since it is rotating here, here is its center of mass. Okay, so a force mg acts on the rod in downward direction, and there will be force due to hinge. So that force we don't know actually. Okay, ये rotate कर रहा है इस तरह से with angular speed omega. Now you see, if you calculate its so angular velocity omega है, अगर हम omega को resolve कर देते हैं parallel to the rod and perpendicular to the rod, so in this angle is theta, so this angle is also theta. So this side component of omega will be omega cos theta, and this side component of omega is omega sin theta. Okay. Since in this direction moment of inertia of the rod is zero, in this direction moment of inertia will be ml square by 3. ठीक है, इसके बाद moment of inertia जो होता है वो ml square by 3 होता है. Okay. Now this rod is rotating with angular speed omega, it is given. Okay, तो अगर हम इसका angular momentum निकालते हैं, देखिए angular momentum, तो since moment of inertia about this axis is zero, so this angular velocity will not contribute to angular momentum. Okay, एंगुलर मोमेंटम सिर्फ मोमेंट ऑफ इनर्शिया, दिस मोमेंट ऑफ इनर्शिया इनटू ओमेगा हो जाएगा. ठीक है ना, दिस ओमेगा साइन थीटा, तो ये हो जाएगा ml स्क्वायर बाय 3 एंड ओमेगा साइन थीटा. दिस इज द एंगुलर मोमेंटम ऑफ द रॉड. ओके, एंड डायरेक्शन ऑफ एंगुलर मोमेंटम विल बी दिस इज द डायरेक्शन ऑफ एंगुलर मोमेंटम. ओके, डायरेक्शन एंगुलर मोमेंटम यहाँ पे एक्सिस ऑफ रोटेशन के अलोंग नहीं है, दिस द डायरेक्शन ऑफ ओमेगा. ओके, नाउ इफ यू कैलकुलेट टॉर्क, torque we know that that is equal to rate of change of angular momentum होता है. Okay, this is the magnitude of torque. Okay, here you see when the rod rotates, see angular momentum is perpendicular to the rod. अभी rod इस और यहाँ पे है, तो angular momentum इस direction में. After some time rod position of the rod will change, so angular momentum will always remain perpendicular to the rod like this. Okay, so the direction of angular momentum will also change. So basically what is going to happen, this is the angular momentum, it is also going to rotate about this axis with angular velocity omega, since rod is also is rotating about this axis with angular velocity omega. Okay, so basically we can say this angular momentum is going to precess like this. Okay, there will be precessional motion of angular momentum. Okay, so torque we can write like this. Torque, see this angular momentum vector is rotating. So when a vector rotates, rate of change of vector is written as omega cross L. That is the rate of change of vector when vector rotates. So that is torque. Okay, so torque will be equal to here ओमेगा क्रॉस एल आप कैलकुलेट करोगे तो ओमेगा एल एंड ओमेगा और एल के बीच में एंगल जो आ रहा है यहाँ पे, यू सी दिस एंगल, दिस इज द डायरेक्शन ऑफ ओमेगा एंड दिस इज द डायरेक्शन ऑफ एल. So this is theta, so this angle is 90 minus theta. Okay, so we can write here omega cross L is omega L cos sin 90 minus theta, so that will become cos theta. Okay, so therefore torque is equal to this much. We can put the value of L here. Okay, now torque if we calculate using force, see one force that is acting on the rod is mg, and the other force will be from the hinge. So if we calculate torque about the hinge, okay, we'll get mg, और ये यहाँ से इसका perpendicular distance निकल जाएगा which will be equal to L by 2, ये होगा length इसका. ठीक है, length is L, so this is L by 2 and this angle is theta, so this perpendicular distance will be L sin theta. L by 2 sine theta. So torque can be written as force. This is the line of force, you can see. This is the line of force. Okay. और यहाँ से जो perpendicular distance ये बनेगा line of force पे, that is equal to L by 2 and sine theta. Okay. So that is equal to omega, and let's put the value of moment, ये angular momentum, that is ml square by 3 and omega sine theta. And so we have put the value of L, and now there is cos theta term here. Okay. So now you see, few things will cancel out. The sine theta will cancel out, m will cancel out. You know? So we are getting here GL by 2, that is equal to, let's see, here m we have cancelled, we have cancelled, L we haven't cancelled. Okay, so let's write here like this. This is L square by 3, and there is omega square, and omega, value of omega was given to be here 3g by root under 3g by L. Okay, so that will become, omega square will become equal to 3g by L, and 1 cos theta will remain here. Okay, that's what you get. So 3 and 3 will cancel out, g will cancel out, L, all the factors will cancel out. So you will get cos theta is equal to 1 by 2. Basically, we get theta is equal to 60 degree. Okay, so we can say that rod is making 60-degree angle with the vertical. Okay, now let's calculate force on the rod. See, this is the center of mass of the rod. Okay, center of mass is moving in a circle of radius. Let's say this is the radius of the circle. And since it is this angle is constant, okay, so circle is so center of mass is only moving in a horizontal circle. It is not shifting vertically. Okay, center of mass is not shifting vertically, so we can say that net vertical force on the rod must be 0. Okay, it is moving in a horizontal circle, so we'll write radial equation of motion for center of mass of the rod. So that is mass into a radial. Okay, so radial force will be actually the net force on the rod. Okay, so that is the net force. Okay, so m mass and omega, this will be omega square r. So we can write like this, m omega square, and here r, this r will be equal to L by 2 sine theta. Okay, so let's put the values. Okay, this is m, omega is given to be 3g by L. Okay, and this is L by 2, and sine 60 degree will be equal to root 3 by 2. So we'll get here, L will cancel out, 3 root 3 mg divided by 4. Okay, so that is the radial force acting on the rod. Okay, this is this radial force will actually come from the hinge. Okay, so hinge is applying some radial horizontal force, you can say. Okay, and hinge will also apply a vertical force. So that vertical force is balancing this mg because it is not shifting in vertical direction. Okay, so this is actually the net force on the rod. Okay, the net force on the rod will be this much. Net force on the rod is equal to 3 root 3 mg divided by 4. Okay, so if you have solved, if you manage to solve this question by any other method, okay, you can just mention that in comment section that you solved it by some other method. Okay, but I think you should also be able to get this answer, okay, if you apply any other method. All right, this question can be done by other methods also. Okay, that's why I'm asking. So I'll be discussing these type of challenging question in other videos also. Okay, I'll be regularly posting some good questions. Okay, and their solution on this channel.